Welcome to SigmaWay's RapidMiner course series, where we will aim to help budding industry professionals and data scientists understand various data analytics processes and show them how these processes are performed in a statistical software like RapidMiner. This module will focus on giving you an introduction about big data and data analytics. The details of the topics covered in this module are analytics overview, where we'll give you a brief introduction regarding the buzzwords, some broad definitions, the different types of analysis, and how to use those analysis. And we'll cover a basic about big data, where we'll cover the basic concept, how it began, its current evolution, and what is data analytics. So let us begin with an overview. The industry of business analytics and data analysis is full of buzzwords that inspire upcoming businesses and give hope to established players for new solutions. So, the fact remains, how does one relate to all these buzzwords and connect to the dots within? Let us try and understand what business analytics means. Business analytics refers to the skills, technologies, practices for continuous iterative exploration and investigation of past business performance to gain insight and drive business planning. Business analytics focuses on developing new insights and understanding of business performance based on data and statistical methods. So what is business intelligence? Business intelligence traditionally focuses on using a consistent set of metrics to both measure past performance and guide business planning, which is also based on data and statistical methods. The difference in both terms is as follows. Business intelligence tries to answer the question of what is happening to the business. It is used to gain visibility regarding the problem. Its purpose is about maintaining of the business, and its enablers are data warehousing, visualizations, dashboards. Business analytics, on the other hand, is trying to predict what will likely happen in the future. It is used for investigation, prediction, and prescription. The purpose of this is to understand how the business will grow and how to find the strategies that will help it grow even further. The enablers for this are data analytics and data sciences. Let us now discuss the various types of analysis. The pictograph correlates the stage, skill level, value add among different types of analyses. Descriptive analysis tries to explain the current situation. It explains the effect of an action. It usually happens at the start of business problems. It is deemed low in skill level as mere pattern observation or financial statement analysis can help us understand what problem is happening. Diagnostic analysis. It tries to help find the reason for a problem. Low to moderate skill level is required as basic statistics is required to find the cause for an effect. Predictive analysis tries to find out when the consequences of the effect will happen. Predictive analysis tries to forecast the future and find out when the problem might arise. It requires a more adept sense of statistical knowledge since it deals with forecasting and modeling. It thus provides more value to a company since countermeasures can be prepared for any future potential loss. Prescriptive analysis aims to find out a solution for the business problem or opportunity. It uses the advanced statistical modeling coupled with future forecasting to come up with a solution to combat or take advantage of any business problem or opportunity. In terms of skill required, it becomes the most important task for a data scientist, so advanced level software knowledge coupled with statistical knowledge is required. And naturally, the value it provides to an organization is high too. Let us give you some examples in how smart organizations use BI and BA. Business intelligence tries to answer what happened. For example, data for the last 5 years says that net profit margins have dipped 5% from quarter 1 to quarter 2 in region 1 despite a 10% increase in advertisements expenditure. Predictive analysis tries to explain what will likely happen. It tries to explain the correlation of NPM with the advertising expenditure per region per season. Prescriptive analysis helps us understand what will be the next action. Which region should we divert to maximize the NPM for the season with respect to the expenditure on ad revenue? These are some of the ways in which BI and BA helps an organization. Now let us discuss what is big data. Big data is defined as large sets of structured, semi-structured and unstructured data that may be analyzed to reveal patterns, trends and associations. It can be characterized by the 3 V's. Data volume, where organizations collect data from a variety of sources including business transactions, social media and information. In short, the volume of the data collected. Velocity explains data streams which are collected at unique speeds which must be dealt with at specific times. Examples would be RFID tags, sensors and smart metering are forcing to deal with data in near real time. Data variety. Data can be structured, numeric in databases to totally unstructured documents like email, video, audio and financial transactions. All of this variety has to be taken care of when doing your analysis. The following graph shows how each of the 3 V's as mentioned before are correlated. It shows how data velocity, data variety and data volume are correlated as they increase in magnitude. Let us now discuss the history of big data. Facebook, Yahoo and Google found themselves collecting data on a large scale and started referring to it as big data. These big data collections took by surprise the traditional and existing statistical systems like Oracle and MS SQL. In early 2000s, researchers developed new techniques like MapReduce, Bigtable and Google File System to handle these kinds of big data requirements. In 2006, Doe Cutting, a technical creator, launched the Hadoop project as an open source version of a big data handling software. Nowadays, big data has begun to span across multiple mediums. From paper, print, computer to internet, there are lots of places one can find big data. Let us now discuss a brief about what data analytics actually means. Why do we need data analytics? When dealing with data in any form, our primary goal is to make sense of it. After that, we perform a variety of statistical and logical operations to basically understand what that data means. It is for the same reason we actually began using charts and diagrams from the data that we had, so that correlation and understanding becomes easier. Our mind is incapable of handling large amounts of raw data and understands visual or conceptual information better. But calculations cannot be purely based on snippets of information. There is a need to process it in a fast, efficient and accurate manner. Thus, computers are employed to make sense of large amounts of data. This began with the creation of data analytics. We will continue with the showcase of the user interface of the RapidMiner statistical software before proceeding further in the course. Thank you for joining us.